Welcome to the lesson. This is KCSE 2013 question number 19, paper 2. The question is about quadratic and cubic graphs. Part A of the question: complete the table below for y is equals to x cubed plus 4x squared minus 5x minus 5. That is 2 marks. So given the values of x ranging from -5 all the way to 2, the function you're supposed to use to fill the table is given there. So that is the first thing you're going to do. Then part B of the question, on the grid provided, draw the graphs of the graph that you're going to have there. Y is equals to x cubed plus 4x squared minus 5x minus 5 in the range given. Then there is part 2. This is a C. Part 1 is the graph to solve the equation that is there. Then part 2, by drawing the suitable line on the graph, solve the equation. So we're going to begin from the first part of the question, where you're required to have the values that you're going to graph. So there are two values that are filled there for -3 and for 0. So let us go straight and use our calculators in order to feed the remaining values. So let's go direct to the calculator. So we are going to begin by filling the first one. So you're going in your calculator, you're going to write the function, and then we shall be substituting the values of x. So let us go direct to our calculators and begin. So the equation as it goes, the first one is -5 when x is -5. So we're just going to substitute here with -5, and then where we have the values of x, we substitute that with -5. That is what you're going to do. So this one is -5 as well. So that gives -5. So the first value when x is -5, can confirm when x is -5. Yes, it is okay. When x is -5, the value of y is 5. So we can fill that. So this one is a -5 as well. So we go to the second one. When x is -4, the same function when it is -4. So I'm going to replace this one with the -4. Let me replace this one with -4. When it is -4, this one you give 15. This one you get 15. The other one, now we can confirm this one for -3. We can confirm that for just for the purposes of confirmation when it is -3, just to see whether we are working well. As you can see, it is 19. So we can go to the other one when x is -2. When x is -2, you get 13. That will give 13. When it is -1, when x is -1, just substituting the function. This is 1. That one you give 3. Then when x is 1, now here you need to change even the positive. So when it is 1, when x is 1, we get that one, the value of y will be -5. When x is 2, when x is 2, the value of y is 9. So that is simply how you're supposed to use the calculator to fill that table, by simply feeding the function and then replacing, and you'll be very careful we have the negative values. So those are the values. Now we should go straight to the graph. So let us go straight to the graph. Welcome. Let us go direct to the plotting and drawing the graph using the table of values that you have just filled, and see how we are supposed to do that. So looking at that table, the first thing will be to determine the scale that you're going to use for both the x and the y axis. Now for the x axis, this is how you do it. Now, this is how you do it for the x axis. So you have for example, the x axis, you just need to look at the values. So the values are beginning from negative, when I look at the -5 to 2, so -5 to 2. So that one I can use to ensure that the graph isn't very small. For the x-axis, here you have to accommodate, you get the largest, which is 2, subtract the lowest, which is -5. So this one you want to get a scale that will accommodate 7 values, a scale that is going to accommodate 7 values. So that one you can use 1 centimeter to represent 1 unit, or you can as well decide, like for this one I've decided to use 1 centimeter, 2 centimeters to represent 1, so that I distribute the graph so that the graph doesn't look very small. In instances where you're given the scale, you're supposed to stick to that scale, but in this question the scale was not given. You're supposed to choose your own scale. Now for the y-axis, let's go to the y-axis. The y-axis, you look at the largest value. The largest value is 19, and then the smallest value is -5. So get the difference between the largest value and the smallest value for the y-axis. So this one will give 24 values. So you must look for a scale that is going to accommodate, looking at the your graph and looking at the values that you have, and also the number of squares that you have for your graph paper. Like mine is around 20, the maximum 20 centimeters. So I need to squeeze the scale, and that is why I've decided to use 2 centimeters to represent 5. 2 centimeters to represent 5. So after every 2 squares, which is 1 centimeter, 2 centimeters, 5, so that I can also ensure that the graph isn't very small. The graph is supposed to occupy at least, a good graph is supposed to occupy at least 3/4 of your graph paper. It should not be too small, again it should not be too large. So that is a scale, and that is how you lay the scale. So here I'll use 2 centimeters represent 5 units. So then for the x-axis, I've decided to use again for the x-axis 2 centimeters, which are 2 squares, represent 1 unit. So those are the 2 scales that I have used. So that one and that one. So those are the 2 scales. Now let us go direct to the plotting and see how we're supposed to plot these. Now we're using the table that we identified. So let me plot. I'm going to use a pen. When you're drawing the graph, you're not supposed to use a pen. You're supposed to use a pencil for the purposes of in case you want to make a correction or to erase something, it will be easier. The reason why I'm using the pen is so that it can be clear and visible. Now the first one is -5, -5 for x, -5 for y. So -5 is here, and -5 is here, and then for me put it a bit higher, so -5 is here, then negative 5 for y, the point will be there. So the other one is negative 4, 15. Negative 4, 15. Negative 4 is here. Then I have to go up to where I have 15. Negative 4, 15. 15 is here. That is where you should have the point. Then the other one is negative 3, 19. Negative 3, 19. Before I forget, you need to understand the size of one small square. Like in my case for the y-axis, you can see I have in between these two squares I have 10. I've got 10 small squares. So to know the size of what one small square represents, I'll take 5, which is represented by 2 squares. Then I divide inside those 2 squares. We have 10 small squares. So meaning that one one small square will represent 0.5. 0.5. So that is how you get it. For this is for the y. This is for the y-axis. That is a small square. Then for the x-axis, you have 1 divided by 10, because 2 centimeters represent 1 unit, and inside those 2 centimeters there are 10 small squares. For the y-axis, 2 centimeters represent 5 units. Then within those 2 centimeters there are 10 small squares. That is how you get the size of one small square. So this will give 1 divided by, so I want to show this one, 1 divided by 10, this one is 0.1. So that is the size of one small square on the x-axis is 0.1. The size of one small square on the y-axis is 0.5. Very important to know that. Now from there, we were at this level, negative 3, 19. Negative 3 in the x-axis, then 19. So meaning in the y-axis, 2 small squares will represent 1 unit. 2 small squares will represent 1. So negative 3, then this is 15, 16, 17, 18, 19. 19 will be somewhere there. So that is why we have 19. So negative 3, then you go up, 19 is there. Negative 2, 13. Negative 2, 13, 13, 10 is here. So this is 11, 12, 13. Yes, 13 is there. And then there is the other one, which is negative 1, 3. Negative 1, 3. So 1, 2, 3. So 1 is 1, 2, 3. So 3 is there. Then 0. 0 is negative 5. For 0, negative 5. 0, negative 5 is there. So it should be 0, negative 5. And then 1, negative 5. 1, negative 5 again. 1, negative 5. 1, negative 5 is there. Then 2, 2, 9. 2, 9. So 2, this is 9 should be somewhere, it should be there. 2, 9. Now there's something that you will notice here, and I want to make it clear. Between for 0, at that point where you have 0, the value of y is negative 5. Then where we have x is equals to 1, the value of y is negative 5. So when you're drawing the graph here, you'll notice here you can't draw. When you're drawing the graph, it must make a curve. You should avoid having a straight line. So to ensure that you're able to draw this curve properly, there's something that you're going to do here, and that is you're going to get the point that is between that point is not given in the table, but you're going to insert that, to introduce that point, to ensure that this curve isn't straight. It must curve at this point, and you see that this is a straight line. So I introduced the point between 0 and 1 is 0.5. So go to the table and use the calculator and use the function given there. So use the function that you're given, you feed in now when x is equals to 0.5. So when x is equals to 0.5, when x is equals to 0.5, what is the value of y? And you notice that that one will give when you feed that, it will give negative 6.375, negative 6.375, which is when you round off, that one will be negative 6.4. You cannot plot all these values, negative 6.375, so you round it off, so negative 6, so this will be 5, 6, 7, so 6.4 will be somewhere there. Negative 6.4 will be somewhere there. Now you notice that now when you're drawing the graph, it will now make a curve at that point. So that is how you plot. That is how you plot. I want us now to draw the graph. Now you have all the points. You have the first point is here, the other one is here, then we show all the points clearly. So first point is here, the second is here, the third point is here, the other point is here, the other plotting is there. You should confirm the other point is there, the other one is here, here there is one, and then here there is one. So now what you need to do is to take a pencil. I'll take a pen, I've explained why, and then you join these points using a straight, not a straight, but using a curve. You should ensure you draw this one, and you be very careful when you draw. Let's start drawing the graph now. All the points are there, as you can see, all the points are indicated there. Now we should draw a smooth curve. So let me turn the paper this way so that I can begin from here. You should use pencil. I'm using a pen, just risking. So you're supposed to draw, ensure that the curve is smooth. Ensuring that the curve is the point that we introduced, that, and then the last point to join. That's that point. So now the curve is there. The curve is there. And as you can see, it is smooth. This one is a smooth curve. Having done that, now we can go. Now the most important thing, ensure that the curve is smooth, then the curve passes through all the points that you have plotted, and also ensuring that the points are plotted correctly. Now let's go to answering of the questions. So let's go to the second question, that is use the graph to solve the equation. So use the graph to solve the equation, and the equation is given there. As you can see, y is equals to x cubed plus 4x squared minus 5x minus 4 is equals to 0. So how do you solve these? So let me introduce another page here. Now this is how we shall do this. So the equation is x cubed plus 4x squared. So x cubed plus 4x squared minus 5x minus 5 minus 5x minus 5 is equals to 0. So this is question C part 1. This is question C part 1. So how do we use the graph to solve this? Now what you're supposed to do, in the first place, the function that we given is y is equals to x cubed plus 4x. This is the function which you have drawn the curve using. That is the function. Now you're required to solve this. So what you do, if we compare these equations and solve them simultaneously, that one should help us to get the solution. This is what I mean, solving the two simultaneously. So solving these, this one and this one simultaneously. So I can bring, this is 0, put 0 there. Then you notice that the right hand side, all these are similar. All these are similar. So if you are solving these equations simultaneously, you subtract, and when you subtract these, you get y minus 0. This will be y, then the whole of these will give 0. That is the first thing you're supposed to do. And you notice that what you get here is this one is the equation of the x-axis. Y is equals to 0 is the equation of the x-axis. So what you should do now, upon getting that, you're supposed now to go and find from the curve the points where the curve has touched the x-axis. That is what you're supposed to do. Points where you look at the intersection points of the curve and the x-axis. The x coordinate at those points will give the solution. The x values at those intersection points. The intersection point of the curve and the x-axis. Alternatively, for solving this, you don't need to use a simultaneous equation. You just need to know also that the whole of this one represents the y. When you look at what we have here, these let me just use a different. So what we have there, that y is that y that is there. So the left hand side of this equation, x cubed plus 4x squared minus 5x minus 5, is y. So therefore the whole of that, if you substitute the left hand side of the equation with y, you get y is equals to 0, and that still will give you the solution, since that will be still the x-axis. To give you y is equals to 0, which is the x-axis. Now let's go to the graph directly and get the points where the curve has touched the x-axis. So let's go directly to the graph and see. So from the graph we check where the curve intersects with the x-axis, and as you can see, there are 3 points. The first point is here, the second point is here, and the third point is there. Those are the points where the curve intersects with the x-axis. So the first one is, I've already indicated this here. The first one is this point, and this point is negative 0. So x is equals to negative 4.8. So that is how you give the answer or the solution for that part. So the next one is this one that is here. This point is negative 0. This 1, 2, 3, 4, 5, 6, 7, around 6, 5. So 1, 2, 3, 4, 5, 6, around negative 0.65. If you approximate that, you get negative 0.7. Then the other point is this, that is here. The other point is here. So that point is 1, 2, 3, 4. And this is x is equals to 1.4. Remember our scale. Don't forget that. The scale that we have used is 2 centimeters to represent 1 unit, so 1 small square represents 0.1. So this point is 1.4. Let me write this one well. So this one is 1.4. So the solution for that part, therefore, using the graph to solve that equation, is x is equals to, so the first one, x is equals to negative 4.8, and then x is equals to negative 0.7, and x is equals to 1.4. An allowance, a slight allowance of around 0.1 is given for these answers. Now let's proceed to the next question. So C part 2, by drawing a suitable straight line on the graph, solve the equation. The equation is given here as x cubed plus 4x squared minus 5x minus 5 is equals to negative 4x minus 1. So let me write these: x cubed plus 4x squared, x cubed plus 4x squared minus 5x minus 5 is equals to negative 4x minus 1, negative 4x minus 1. So you're supposed to draw, by drawing a suitable straight line, solve that equation. By drawing a suitable straight line, draw that equation. Now there's something that you notice here. I want you to observe this part. That function is y. The whole of that is y. That is from the question itself, the function is given there. It is y, as you can see, it is there. So that function represents y. The whole of the left hand side, that is y, is equals to negative 4x minus 1. And when you look at this is the equation of the line that we require to draw. That is the equation of the line that we need to draw. Now for us to draw that, of course we'll need some points which I've already calculated here. You need 3 points to draw this line, so you can use 2, but of course for the purposes of accuracy you can use 3. So let me use 3. I'll use 0, negative 1 and 1. Those points are okay. So now we are substituting in this line, equation of this line. When x is 0, y will be negative 1. When x is negative 1, this will be 3. Then when it is 1, when x is 1, this will be negative 5. So these are the points that we need to plot and draw a straight line. So let's go straight to the graph and plot those points. So these are the points that we need to plot: 0, negative 1, negative 1, 3 and 1, negative 5. So let's go to the graph and do that. So 0, 0, this is 0, negative 1, 0 and negative 1 is here, 0, negative 1, that will be the point there. Then we have negative 1, 3, negative 1, this negative 1, 3 is up here, negative 1, 1, 2, 3. It will be exactly at this point. Negative 1, 3 will be there. And then you can indicate this one like this so that it can be seen properly. So the first point, 0, 0, negative 1 is here. Negative 1, 3 is there. Then the last one, 1, negative 5. 1 and negative 5. 1, negative 5 is here. So those are the 3 points. Now we draw a straight line using those points. We draw a straight line. When you're drawing the straight line, we should ensure that the line is extended in such a way that it touches the curve at all the points. So this is the line, so that is the line, so that is the equation of the line. Y is equals to, so y is equals to negative this is negative what? Negative 4x minus 1 equation. Now let us come to now answering the questions using we're supposed, by drawing a suitable straight line, solve. We are supposed to solve. So what we do check the intersection of that line and the point, the intersection of that line and the curve. Let me repeat that. We check the intersection point of that line and the curve. And when you look at the graph, the line and the curve intersect at 3 points. So that is the first point of intersection, the second point of intersection, the third point. So we read the x coordinate at those points. So we can start with this one. We can start with this. We draw a straight line here. From this point, we can draw a straight line to read that is the point of intersection. This is the point of intersection. So we read the x coordinate of that intersection point. So x coordinate there is given by, so x, I will write here, x is given by -4, which is here. X is given by -4. That is the first solution. The second solution is here. The other point of intersection of the curve and that line is here. This is the point. So you also draw another line here. So we read the x coordinate. This is after drawing the straight line down, straight down to the x-axis. We read the x coordinate there is x is -1. That is the point. And then the last point is here. The last point is here. The other point of intersection down here. So we also draw a straight line up there. And the x coordinate here, this point is here, is 1. So x is equals to 1. So there are 3 solutions. So we read the x coordinate of the intersection points. So the first point, x is equals to -4. The second, x is equals to -1. The third one is x is equals to 1. And that is how you're supposed to give the solution and how you're supposed to work out that question.